Every emergency radio you own will die. Every battery you stockpile will expire. Every solar panel you mount can be smashed, stolen, or buried under snow. But in 1901, Nikola Tesla filed a patent that made all of that irrelevant. He demonstrated that a simple loop of wire connected to nothing, powered by nothing, could pull electrical energy directly from the electromagnetic radiation already saturating the air around you. The power companies called it impossible. Then they called it dangerous. Then they made sure you never heard about it again. Here is what Tesla actually discovered. Every radio station, every cell tower, every Wi-Fi router, every electrical wire in every wall of every building is constantly broadcasting electromagnetic waves into the environment. These waves carry energy, not much per wave, but they never stop. They are everywhere. And they are free. A wire loop acts as an antenna. When electromagnetic waves pass through the loop, they induce a tiny alternating current. This is the exact same principle that makes your car radio work. The radio does not generate the signal. It captures energy that is already there. Your car radio has been harvesting ambient electromagnetic energy since the day you bought it. You just never thought of it that way. Tesla's patent number 685.957, filed February 19, 1901, described a device for the utilization of radiant energy. The concept was simple. An elevated antenna connected to a capacitor. The antenna absorbs ambient electromagnetic energy. The capacitor stores it. When enough charge accumulates, it discharges through a load. Light, heat, motion. From nothing but the invisible radiation already in the air. The patent drawings show a polished metal plate mounted on an insulated support, connected through a conductor to one plate of a capacitor. The other plate is grounded. As radiant energy strikes the elevated plate, it charges the capacitor. When the capacitor voltage exceeds the breakdown voltage of a small spark gap or switching device, the stored energy discharges through whatever load you connect. Tesla demonstrated this with a small incandescent lamp. The lamp glowed. No wires from a power source, no battery, no generator. Just a metal plate in the air and a capacitor. The physics behind this is not mysterious. It is taught in every electrical engineering program in the world. Maxwell's equations, published in 1865, predict exactly this behavior. An electromagnetic wave consists of oscillating electric and magnetic fields. When these fields encounter a conductor, they force electrons to move. Moving electrons are electric current. Current through a resistance produces heat or light or motion. The energy was always there. Tesla simply showed how to collect it. The modern version is even simpler than Tesla's original design. You need a coil of copper wire, 50 to 100 turns, roughly 6 inches in diameter. The coil acts as a loop antenna, tuned by its physical dimensions to resonate at specific frequencies. Connect both ends to a germanium diode. The diode rectifies the alternating current into direct current, allowing charge to accumulate in one direction. Connect the output to a small capacitor, 10 microfarads at 25 volts, that is your storage. The total cost is under $2. The wire is $50 for a 50-foot spool of 28-gauge magnet wire at any electronics store. The diode is 0.10 for a 1N34A germanium diode. The capacitor is 0.25. You probably have the rest in a junk drawer right now. Let me explain why germanium specifically. Silicon diodes, which are far more common, have a forward voltage drop of about 0.6 to 0.7 volts. That means any signal below 0.6 volts simply cannot push current through the diode. It is blocked. Germanium diodes have a forward voltage drop of only 0.2 to 0.3 volts. When you are harvesting microvolt and millivolt signals from ambient radiation, that difference between 0.6 and 0.2 volts is the difference between a device that works and a device that does nothing. Germanium is the key. Silicon is the wrong material for energy harvesting. In testing near a standard AM radio tower at 1 kilometer distance, this simple loop produces 50 to 200 millivolts. The voltage depends on tower power, frequency, and antenna orientation. Near high-voltage power lines, the numbers jump to 500 millivolts or more, due to the strong 60 Hz electromagnetic field radiating from the conductors. Near a Wi-Fi router, a properly tuned loop at 2.4 GHz can capture 10 to 50 microwatts continuously. That does not sound like much, and individually it is not. But energy harvesting is not about bursts. It is about patience. It is about accumulation over time. Consider this analogy. A single raindrop does not fill a bucket, but if you leave the bucket outside for a week, it overflows. Energy harvesting works the same way. A supercapacitor charged by ambient RF energy can accumulate enough power in 24 to 48 hours to transmit a short radio burst. That means an emergency beacon that never needs batteries. A distress signal that works when everything else has failed. Powered by nothing but the invisible energy the atmosphere already contains. Let me walk you through the specific construction of an emergency RF harvesting beacon. Start with 100 turns of 28-gauge enamel-coated magnet wire wound on a 4-inch diameter form. A PVC pipe, a cardboard tube, or even a rolled magazine works as a form. The coil's inductance will be approximately 300 to 500 microhenries, which resonates in the AM broadcast band when paired with a 100 to 500 picofarad variable capacitor. Connect the coil to a Schottky diode, which is even more efficient than germanium for high-frequency operation. The BAT46 Schottky diode has a forward voltage of only 0.15 volts and costs less than 0.05 in bulk. Connect the diode output to a 1 farad, 5.5 volt supercapacitor. This is your energy reservoir. The supercapacitor charges slowly from the harvested RF energy. A charge controller circuit, which can be built from a single Zener diode and a transistor, prevents overcharging. When the supercapacitor reaches 3.3 volts, it has enough energy to power a low-power microcontroller like the Atney 85 for approximately 5 seconds. In those 5 seconds, the microcontroller can wake up, read a GPS module, and transmit a burst of location data on a license-free frequency. The total parts cost for this emergency GPS beacon is approximately $8. It has no batteries to die, no solar panels to break, no moving parts to wear out. It runs on the electromagnetic radiation that already fills every square meter of the atmosphere. It will transmit your GPS coordinates once per day every day for the rest of your natural life, without you ever doing anything. The military figured this out decades ago. DARPA's WARP program, Wireless Ambient Radio Power, funded extensive research into powering remote sensors using nothing but ambient RF radiation. The research was conducted at multiple universities including Georgia Tech, MIT, and Duke University. The sensors had no batteries, no solar panels, no wires. They harvested energy from nearby cell towers and broadcast their data using the same captured power. The WARP program demonstrated sensors that could operate indefinitely on harvested RF power at distances up to 5 kilometers from a cell tower. The sensors monitored temperature, humidity, vibration, and chemical composition. They reported their data wirelessly using the same captured energy. The program ran from 2009 to 2014. The results were impressive enough that significant portions were classified. The technology was not deployed for civilian use. The stated reason was efficiency limitations, but the actual reason requires understanding the economics of energy. If the public understood that ambient electromagnetic energy could be harvested for free, the implications would be devastating for the power industry. Not because RF harvesting replaces the grid. It cannot, not at these power levels, but because it proves a principle that the industry has spent a century denying. Energy surrounds you. It is already there, and capturing it costs almost nothing. The crystal radio is the oldest and most dramatic proof of this principle. Built by millions of hobbyists since the 1920s, a crystal radio has no battery, no power supply, no plug, no external energy source of any kind. It uses a long wire antenna, typically 50 to 100 feet, a coil of wire, a germanium diode, originally a galena crystal and cat's whisker, and a high-impedance earphone. The electromagnetic energy from AM radio stations physically vibrates the speaker membrane. You hear music, news, emergency broadcasts, all powered entirely by energy that was already in the air. The radio station paid for the electricity to transmit the signal. You harvest it for free. No one disputes that this works. It is taught in physics classes. It is demonstrated in science fairs. It has been reproduced millions of times over 100 years. Yet somehow, the concept of scaling this principle up has been systematically ignored by every major energy company for a century. The reason is not technical, it is economic. You cannot build a utility company on energy that customers can harvest for free. Here is the scaling math that the energy industry does not want you to understand. A single loop captures microwatts. 10 loops in series capture milliwatts. 100 loops organized in a phased array capture useful watts. A properly designed rectenna array, which stands for rectifying antenna grid, can capture meaningful power from dedicated RF transmitters at efficiencies approaching 80%. The rectenna concept was demonstrated by William C. Brown at Raytheon in 1964. He transmitted 2.4 gigahertz microwave power across a room and converted it to DC electricity with over 90% efficiency using a rectenna array. He then scaled the experiment to transmit power from a hilltop to a valley floor over a distance of 1 mile. The demonstration was successful. The technology worked. It was 1964. That was 62 years ago. The technology has been refined, improved, and demonstrated repeatedly since then. It works, it is proven, and it is still not available to you. Researchers at Georgia Tech published a paper in 2021 demonstrating a printed rectenna on flexible material that harvests energy from 5G millimeter wave signals. The device, printed on a flexible substrate using standard inkjet printing technology, produces enough power to continuously operate IoT sensors. The antenna, rectifier, and power management circuit are all printed on a single sheet of flexible material that costs less than $1 to manufacture. The paper was published in the journal Scientific Reports. It is publicly available. The technology exists. It is not theoretical. It is not a prototype in a lab. It is a printed, flexible sheet that harvests 5G radiation and produces usable electricity. The manufacturing process is simple enough for mass production. Japan has been experimenting with space-based solar power that beams energy to Earth via microwaves since the 1980s. The Japan Aerospace Exploration Agency, JAXA, has a detailed roadmap for a commercial space solar power station by 2040. The ground receiver for this system is a rectenna array, the exact same technology Tesla described in 1901, the exact same technology Brown demonstrated in 1964, the exact same technology Georgia Tech printed on flexible material in 2021. Your version does not need space-based transmitters. It does not need 5G towers, though those help. It does not need anything except the electromagnetic radiation that already fills your environment. Here is the practical survival application. Build step 1. Crystal radio with emergency reception. String a long antenna wire, 50 to 100 feet, between 2 trees. The higher the better. Run the wire to a coil of 80 turns on a 3-inch form. Connect the coil to a germanium diode. Connect the diode to a high-impedance earphone, at least 2,000 ohms. Ground the circuit to a metal stake driven 12 inches into moist earth. You now have an emergency radio that works indefinitely with zero power input. You will receive AM broadcast stations at distances up to 100 miles. Total cost, including the earphone, is about $5. Build step 2. Ambient energy harvester for sensor power. Wind 100 turns of 28-gauge magnet wire on a 4-inch PVC form. Connect to a BAT46 Schottky diode. Connect the diode output through a 100-ohm current-limiting resistor to a 1 farad, 5.5-volt supercapacitor. Attach small aluminum foil sheets, 6 by 6 inches, to both the top and bottom of the coil as ground planes. These improve coupling to ambient fields. Position the device near any source of electromagnetic radiation. Near a power line, the 60 Hz field will charge the supercapacitor to 3 volts in approximately 12 hours. Near a cell tower, the RF energy will charge it in 24 to 48 hours. Near a Wi-Fi router, positioning the coil within 3 feet will charge it in 6 to 8 hours. Build step 3. Emergency GPS beacon. Connect the charged supercapacitor to an ATtiny85 microcontroller through a voltage regulator. Program the microcontroller to wake every 24 hours, read a GPS module, and transmit coordinates on 433 MHz using a simple ASCII transmitter. The entire burst takes less than 2 seconds and consumes approximately 50 millijoules. The supercapacitor stores over 15 joules at 5.5 volts. That is enough for 300 transmissions before needing to recharge from ambient energy. The emergency beacon version costs $8 in parts. Radio beacon operates indefinitely. No batteries to die. No solar panels to break. It runs forever on energy that was already there. You can build it in an afternoon with a soldering iron and basic electronics knowledge. Tesla knew this 125 years ago. The power companies knew it too. That is exactly why you have never seen it on a store shelf. The technology is not complex. A child can build a crystal radio. A hobbyist can build an energy harvester. An engineer can build a beacon. The components cost less than a fast food meal. The physics has been understood for over 160 years. The wire loop does not replace your electrical grid. It does not power your house. It does something more important. It proves that energy independence is not about generating power. It is about understanding that power is already everywhere around you. You just need to know how to capture it. The electromagnetic spectrum is the largest untapped energy source on the planet. Every transmitter ever built is feeding energy into this invisible ocean. Every power line radiates. Every transformer hums with wasted energy. Every Wi-Fi signal that passes through your walls carries joules of energy that dissipate into nothing. A properly designed harvesting network could capture a meaningful fraction of this wasted energy. Not enough to power cities, but enough to power sensors, beacons, emergency communications,